In this example, we're having to calculate the maximum amount of deck cargo at a kg of 12 to load, so that we'll load it in port A, so that we'll arrive in port B with a GM of 0.4. Again, in this example, our KM is constant. We know that GM equals KM minus KG. So we know our final GM, we know our final KM because it's constant, therefore we can find the final KG. And we know that KG is total moments over our total weight. So this is the value that we know. So if we can do the table and put various values in, we should be able to solve the problem. So we start off with our displacement 11,600 at 7.8. During the passage we're going to consume these various amounts of diesel oil, fuel oil, water, stores, etc. at those kgs. So of course obviously we need to subtract those. Okay, we need to subtract those to work out the problem. And the cargo is going to be, the deck cargo is going to be at a kg of 12. So what we don't know in this problem is the amount of cargo. We do know its centre of gravity, but we don't know the amount of cargo. So how we solve this problem? Draw up our table. First value is always our initial displacement, kg moments. There's our diesel oil, fuel oil, water and stores, all subtracted because we are using them up during the voyage. And here's our deck cargo that we add, but of course it's x because we don't know the value, kg 12, therefore the moments are 12x. Add them all together, or well in our case subtract all these and then add x to it, so it's 11,270 plus x, 88,635 plus 12x. We know that final kg is total moments over total weight. We know the final kg, which is 8.1, because we're told that our km is 8.5 and our final gm is 0.4, so our final kg must be 8.1. So 8.1 equals total moments over total weight. Multiply this out, 8.1 times this value equals that value, so 8.1 times that equals that. 8.1 times 11,270, 8.1 times x equals that value. Take 8.1 over to that side, it becomes a minus 8.1x. Take the 88,635 over to that side, that becomes a minus. We end up with 2652 equals 3.9x. Therefore x must be 680 tonnes of deck cargo to load. So if we load 680 tonnes of deck cargo at a kg of 12, we will arrive at our final port with a kg of 8.1. And if you wanted to double check that, you could again always work backwards, having put in this value here, 680 tonnes, just work it through again and you'll end up with the 8.1. So it's really a mathematical rather than a stability problem, this, in the sense that we have to use x and 12x. And the stability side is straightforward, that's the weight times the kg gives the moment. So that's how we would solve example 2.